Hello everyone, today let's solve the problem number 287, find the duplicate number. So the question itself, the question name itself indicates that we need to find the duplicate number, right? So let me read out the question load anyway. So here in this case, we have been given the array nums of size n plus 1, size n plus 1, where each number is in the range of 1 to n, where each number is in the range of 1 to n. Exactly one number appears more than once. Here in this case, exactly one number appears more than once in the array, means we have one duplicate number. For one number we will be having one duplicate number, right? So we have been given array nums of size n plus 1, where each number is in the range 1 to n. Exactly one number appears more than once. It can be more than twice, right? Can be more than twice as well. So we have to return the duplicate number without modifying the array. So this is very important. So we have to return the duplicate number without modifying the array, and using the only constant extra space. So this part of the question is very important. So we need to return the duplicate number without modifying the array and using only constant extra space, and we have to use only constant extra space, right? So I hope this part is completely clear, man. Example one, whatever I spoke now, right? So I hope this is clear. So not the example one, question one. So let's consider the example one now. So here we have this one, 2, that is repeated twice, right? So we have to return 2. Let's come to the example 2. We have 3 that is repeated twice, right? So we have 3 twice in the array. So here we have to return 3, and we have 3 repeated almost 5 times, right? So we have repeated 3 5 times. So we have to return 3 as well, 3 for this one as well, right? So I hope the question part is completely clear. As we are completely familiar with the question and this one examples, they have given us wonderful examples just for the sake of understanding. Let's do one thing. Let's quickly discuss the approach followed by the this one. What do we call? Let's quickly discuss the approach followed by the complexities, and then let's write the code. Initially, let's discuss the approach first. So here approach, let's consider the first example. So just give me a second here. Yeah, here let's consider the first example, this one I'm speaking of, right? So let's consider the first example. Nums we have 1 3 4 2 2, 1 3 4 2 2. So let's think of the nums as the linked list here. So let's consider this one as the linked list. First thing that I want to tell you here is we will be going with the linked list approach. We will be going with the linked list approach. We'll be making use of the operations that is provided by the linked list in Java programming language, right? So here we will consider this one as linked list. Let's consider, or let's think of the nums as linked list, where index points to the next node, nothing but I to the nums of I. So here 1 to 3, this one 1 to 3, and this one 3 to 4, 4 to 2, and 2 to this one, sorry, 2 to, so that's this one, 2 to 2, this one. So let's think of nums as the linked list, where index points to the next node, I to nums of I, right? So we have to build the list now. We have to build the list. So initially it starts with a 0. Initially it starts with a 0 index. So as I've said in the previous sentence, so this is the linked list. We just considered the linked list. So we have to point the index to the next node. We have to point the index to the next node. Nothing but here 0 will be pointed to 1, 1 will be pointed to 3, same thing. So we'll start, this is 0 index, right? The same thing, 1 to 3. So this one, uh, 3 will point to the 2 here, 3 will point to the 2, this one, and 2 to 4, 2 to 4 here, and 4 to 2, 4 to 2, right? So here you can clearly see this part. Just concentrate on this part. So here we are pointing the index to the next node. We are pointing the index to the next node. This is 0 based indexing. So this is fine. 0 to 1, 1 to 3, 3 to 2. So this one, 3, this one index we are speaking, 3 to 2, 2 to 4, 2 to 4. This one I'm speaking of, 2 to 4, and 4 to 2, and 4 to 2, this one, 4, this one, 4 value, 4 to 2. So here you can clearly see this one forms a cycle. This one forms a cycle. A cycle is formed at 2, basically. This one I'm speaking of, right? A cycle is formed at 2. A cycle is formed at 2, basically, right? So here in this case, what we'll do, as we have formed a cycle, we have the this one duplicate value for the 2. We have the duplicate value for the 2, and we will this one return this value. So the output that we got here is 2, which is equivalent to the output they have mentioned for the this one first example. So basically we will be going with the this one tortoise and hare algorithm. Tortoise and hare algorithm, one of the important algorithms to solve the most of the linked list problems, right? Especially uh, when we have to detect the this one cycle, right? Cycle in the list. So in that case it will be really helpful, right? Floyd's algorithm or the tortoise and hare algorithm, right? So I hope this part is completely clear, man. So we will be making use of the tortoise and hare algorithm. Yeah, so we will let's write the code for that. I hope this part is completely clear, man. What we will do, this part is completely clear. Now we are completely familiar with the approach. As we are completely familiar with the approach, let's quickly discuss the complexities and then let's write the code. Here what will be the time complexity? Overall time complexity would be big of n, because each pointer moves at most 2 n steps here, 2 n steps, because we are making use of the tortoise and hare algorithm. So one will be slow and one will be the fast pointer, and fast slow moves 1 step at a time and fast moves two steps at a time, right? 2 steps at a time accordingly with the tortoise and hare algorithm. If you don't know tortoise and hare algorithm or the Floyd's algorithm, so I have we have discussed, or we have some important algorithm, 24, I think 20 plus algorithms I have uh, we have discussed already. So that is on the JavaScript, you can just look into it. The same thing will be applying in the Java, it doesn't matter, right? So algorithm is same. We have discussed that one by making use of the programming language JavaScript. So here we'll be discussing, we have discussed already, right? So you can just look into it, or you can just check my this thing GitHub, where we have something called 24 algorithms, right? 24 important algorithms, I think. You can just fetch the name 24 important algorithms, right? Directly you'll get it, right? In my GitHub. Right, so within that I have explained this one tortoise and hare algorithm or the Floyd's algorithm, right? So we have discussed this one already, right? So this is fine. So overall time complexity would be big of n, where each pointer moves at most 2 n steps, basically 2 n steps. Sorry, not 2 to the power of n, 2 n steps. So what will be the space complexity here? The space complexity would be, overall space complexity would be big of 1, because we are not making use of any extra space and we are making use of only pointers. We are making use of only pointers. So this would be the total time complexity and this would be the total space complexity. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of 1 respectively. So I hope the complexities part is completely clear. Now as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. Initially what we'll do, um, nothing but the step 1. So we have to detect the cycle using slow and fast pointers. Nothing but we have to go with the tortoise and hare algorithm, right? So first let's do that. So let me assign slow to nums of 0 and also fast to nums of 0, and then we will move the slow 1 step and fast 2 steps, right? So here this will be at the here as well, at the first index as well, slow and fast pointers initially. So let's make use of the do while loop here. Do let's move the slow by 1 step, means slow. Let me assign this one to the nums of slow, and it's been a long time that I have made use of the do while actually. So right, so let's assign this one fast to nums of this one, nums of fast. This is fine. So let me come out of this one entirely. So now let's go with the while, means here we have to keep moving until they meet inside the cycle, right? In the first case, in our example, the first example that we considered, cycle was formed in the 2, so that is the reason we return 2, right? So here we have to keep moving until they meet inside the cycle. So let's go with the while. We have already considered do here. While of slow not equal to fast, here slow not equal to fast, within the while loop what we need to do, the next step or the step 2, we have to find the entry point of the cycle. Nothing but that we have to find the duplicate number. For that let's write the code, means to find the entry point of the cycle or the duplicate number, we need to carry on further. We need to write the code, right? So whatever we discussed in the approach, let's articulate the same thing in the form of code. So here in this case, slow, let's assign this one to the nums of 0, right? Let's assign this one to the nums of 0. So we are just resetting slow to start here. So again, one more while loop inside the while condition. So here this will be while slow not equal to fast again. So what we'll do here, we will move both by one step, slow and fast by one step. So this will be slow equals nums of fast, sorry, nums of, it has to be slow itself, right? We are considering for slow. So this one has to be fast equals nums of fast. So this is fine. I hope this part is completely clear. The next part here would be the last part. So did I know one thing? So this is fine. How we got the extra this thing here? Uh, did I miss anything? Extra bracket, how we got here? So we have made use of the bracket here. Just give me a second. While loop, this one we are closing here. This one, this is fine. Do this one we are closing here itself. This is also fine. And these two here fine. So two brackets have to be there, right? So we are closing this one here, and eh, one more while loop I have considered here. So this do while we are considering, right? So here I have got confused, man. So this one do while we will stop here, while slow not equals to fast. So I thought we'll be writing while loop. It's been a while that I haven't used the do while, to be frank, right? So I got confused here. This is fine. Let me remove the this one. What do we call it? One bracket here. So we are left with only one step here. We have to return the entry point of the cycle, that is nothing but the duplicate number. In our case it is slow, right? So we have to return slow. Sorry, I got confused here. So do while, I have forgotten really how to make use of the do while, man. It's been a while I have used the do while. So just ignore this part. So I have made it correct now. So let me format the code once and let me hit the run button. So now, yeah, you can clearly see here the sample test cases are getting passed once. The code works absolutely correct. Let's see whether this works for all the test cases. Let me hit the submit button. So here you can clearly see all the test cases are getting passed once. The code works absolutely correct in this case. The code works absolutely correct in this case, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.